the premiere has started, I feel. Yeah. So hi guys, I'm Roshan from Dudes here, and I am finally here after an eternity. So for the past 2 weeks I had my examinations going, and due to that reason I wasn't able to post some videos. But after 2 weeks I'm finally here, and I'm really happy to continue on with my Python series. Okay, so this is session number 4 of a Python series, and today we are going to learn about numerical Python and arrays. So what is numerical Python? As you can see on the screen, numerical Python is denoted as NumPy. Okay, numerical Python is denoted as NumPy. You might have heard this term if you're into coding or something. So what is NumPy? What is numerical Python? So for example, you're old, okay, and you're studying in 12th grade, okay, you're studying in 12th standard, but you have to continue from first grade to go to that 12th standard, right? So first standard acts as a foundation, first grade acts as a foundation for you to continue on to 12th grade. So similarly, for example, if you want to do some complex calculations and scientific experiments, maths acts like a foundation. So math is a foundation to scientific calculations and experiments. So similarly in Python, this NumPy, what we have here, NumPy acts as a foundation for all the Python code. So currently, okay, NumPy has various things, but currently more than 5,000 packages have NumPy as a dependency. Means more than 5,000 packages in Python depend on NumPy, okay, depend on NumPy to put all the coding. So NumPy is basically a package, okay. So this NumPy has features, and these features can be classified into the following 3 types. So NumPy, let me just write that down. NumPy can be classified into 3 types. First is mathematical functions. Okay, as I told you before, maths is very simple, and in Python, you can actually do math. Mathematical functions. Next is random submodule. Okay, random submodule. We won't be going into that in this episode, but next feature is what we're going to really go inside this episode, this episode, and that feature of the NumPy is called ND array. Okay, this array object, okay, ND array object. So what is an array? An array is kind of like tables, okay, if you know what tables are. So tables, a tabular method. So for example, if you have numbers, okay, it arranges those numbers in a tabular method in the form of rows and the form of columns. So NumPy, we know what is NumPy now, okay, and then we got into the basics like why NumPy and stuff, but let's start with the actual code. Okay, if you have followed from my first series, I told you to download Python from Anaconda installer, right? I told you to download Python from Anaconda, and the reason I told you to do this, because Anaconda installs Python along with NumPy as a default. Means you don't have to separately download NumPy. Okay, it's a default installation. Okay, for others, you can do. So for example, you already download NumPy. Okay, it's called pip install. Okay, pip install NumPy. But since we have already downloaded NumPy along with Anaconda installer, we have to import NumPy, because you can't just type NumPy, do this, do that in code. So how do you import NumPy? Just how you say, import NumPy. See, import NumPy as NP. Okay, this NP is an alias. Okay, means the NumPy is denoted as NP, because you can create it as any alias. But then, for example, if you want to do some code and you want to you're referring to some other person's code, because since NP is the most commonly used alias in the entire world, most people will choose NP as the alias for NumPy. So let's say import NumPy as NP. Okay, so once you import NumPy as NP, it will be imported in your Jupyter session. Now, for example, there are many versions, like NumPy version 1, 2, 3, etc, etc. Okay, so for example, I believe the latest version is 1.19.4 something. So you can check which version of NumPy you're currently using. Okay, which version of NumPy you're currently using. You can do that by typing the alias NP dot underscore underscore version underscore underscore. It sounds like a username, right? Okay, so as you can see here, version 1.18.5, 1.18.5, that is the version of NumPy we are using in this, we are using in this episode. Okay, and NumPy, as I told you, has many different types. Okay, we already did, we already imported NumPy, and we also checked the version. Now let's move to the second part. Okay, and that is arrays. Okay, so arrays, as I told you before, arrays are a tabular method. Okay, arrays from list. Okay, so arrays, what are arrays? Tabular method. So for example, I can type, let's create a variable a equals, okay, we'll set the variable to say NumPy NP array. Okay, and what do you want the array to contain? Okay, as I told you, NumPy, follows only its set of integers, and like for example, it is homogeneous. Okay, if you know what that means, homogeneous means it will only accept one type of say type. Okay, one type of data, and that is integers. Okay, so for example, we can type NP array and we want it to contain some integers. For now, let's just keep it simple. Okay, first rounded brackets, then square brackets, and within the square brackets, let's type 1, 2, 3, 4, 5. Simple. These are the first 5 integers. And now when I execute this, nothing happens because I haven't printed it, or I haven't given this as an output. So let's type print in round brackets a. As you can see, it prints 1, 2, 3, 4, 5 because that is what we came in this array. Now arrays can be many dimensional. Okay, and ND array is multi-dimensional. Okay, that's what ND stands for, n dimension, n number of dimensional, multi-dimensional. So for example, we gave 1, 2, 3, 4, 5, and now for example, I kept a shape and enter, gives 5 because 1, 2, 3, 4, 5. You got it? N shape means values. So now for example, I can keep b, and b, let's set another variable b. Okay, what shall we call this variable b? This variable, it can be our first variable np array. Np dot array. And now let's change this method a bit. A is equal to NP array 1, 2, 3, 4, 5. But then let's keep variable b, our first NP array. But let's change the method a bit. Let's change the formula a bit. So square brackets, and within the square brackets, another set of square brackets because this denotes that formula. And let's keep it 1, 2. Okay, 1, 2. And then let's say 3, 4 and 5, 6. Okay, 5, 6. So now we have arranged these. Okay, now we have arranged this in, this is the same numbers, but then okay, we have taken an extra number, that's not a problem. So these are okay, they're same numbers, but we have grouped them. So the first group contains of 2 values, second group consists of 2 values, and the third group consists of 2 values. So we kept 2 values, and let's execute this. Okay, let's execute it by typing b or print b, doesn't matter. See, now you see the now you see why we use an array. An array is a tabular method which uses rows and columns. So as you can see here, this array consists of 1, 2, 3, 4, 5, 6. Okay, because we wanted 3 rows because we denoted by using 3 groups, and within those 3 groups we used 2 values, which suggests that we need 3 rows and 2 columns, and that is exactly how Python has identified it. So Python identified that okay, the user wants us to create an array using the following integers, but in the form of 2 columns and 3 rows. So as you can see, 1, 2 in first row, 3, 4 in the second row, and 5, 6 in the third row. Now, for example, I can type row for the row and col for the column, and I can type b dot shape, because shape is a value, right? How many values are there? And if I execute, execute say row, I can execute row 3 because it identifies that 3 rows, and similarly call will find 2 rows. So this is an easy method to see, how many rows and columns are actually there in your script. Now we did that. Now for example, you wanted to print out a certain number of integers a certain number of times. So for example, I want Python to print out say the number 0 10 times or the number 1 10 times. So instead of just typing 0 comma 0 comma 0 comma, that will take a lot of time, right? So simply just type np zeros, and in the bracket just type how many times you want. So for example, I want it 10 times, and when I execute this, it creates an array. So see, as you can see, 0 0 0 0 0 0, it has showed it 10 times. Notice the decimal point over here suggests that this is a floating point number, a float number. Similarly, if I want this to say the number of ones, so I can just for the number of ones, just let's change it 0 to 1. So instead of np zeros, np ones. Similarly, it creates an array with the float number 1 1 1 1 1. So number 1 has been scripted 10 times. Now for example, if you want to create an actual table, like an actual table, and you want to have a certain number running through it, we use what is called an identification matrix. So we suggest we do that by using np.I. It's not that I, but EYE. So identification matrix. So for the identification matrix, use EYE. And for example, I want the number to run through it diagonally, but what we're actually stating is a number of rows and columns. So if I say 3 and execute, as you can see here, an array is created which is a 3 by 3 square, with the number 1 as a default running through its middle. So I can change this number to say 4. It's a 4 by 4 square with the number 1 running through the middle. I can say 10. So it has a 10 by 10 square with the number 1 running through the middle. So simple. Now, for example, I don't want just a number running through the middle. I want the entire table. Okay, I just don't want a number running through the table. I want the entire table, to be covered, to be filled with just one number. Okay, for example, I just want the number 10 to be, filled with the entire table. So it has like 3 rows full of 10s, 3 columns full of 10s. So instead of doing, npi, we use np full, because you want the full array, full tabular form. You want the full array to be filled with the certain number. So np full. Now we denote, how many, we denote how many rows and columns. So in rounded brackets, we use another rounded brackets and 5 comma 5. Okay, 5 comma 5, a simple 5 by 5 square, and say we want the number 10 to be repeated. Okay, we want the number 10 to be filled in that 5 by 5 square. So if I execute this, as you can see, it creates an array. So it creates an array with 10, the number 10. Okay, arrange that array in the form of 5 rows and 5 columns. I can change this to say 6 rows and 5 columns, or I can keep say 5 rows and 6 columns. Okay, 5 rows and 6 columns. You can keep any number. I can change the number value as well, say 9, or yeah, so you can do all those kind of stuff. Now for example, b and dim, n number of dimensional, and if I execute this, it is 2. Why? Because as you can see here, 1 2. The n dimensional is 2, because our variable b has 2. Now for example, I say b size, okay, b dot size, it is 6. Why 6? As you can see here, 1, 2, 3, 4, 5, 6. So b dimensional is 2 because it's 2 dimensional rows and columns, but b size is 6 because it has 6 characters, 6 values inside that array. Now I can type say b, dimensional type, bd type, okay, bd type, and execute this. It shows that the d type, the dimensional type, is integer 64. The number 64 is just default, but then it denotes that there are integers inside this array. Okay, so for example, if I just type b, it prints out the array. But I can, as I told you in last class, in the list and dictionary, we can find out which character of dictionary we want, or which character in the list we want. So similarly in arrays, I can just type b in square brackets. I can type 1, 0. Just for example, it will show 3. Why? Because as I told you in last class, in Python the numbering starts from 0, not 1. So this is line number 0, this is line number 1, and this is line number 2. Similarly, this is character 1, this is character 0, this is character 0, this is character 0. Whereas this is character 1, character 1, character 1. So b1, 0 is equal to first row, which is, this is row 0, this is row 1. So first row and the zeroth character means first row and the zeroth character. So this is character number 0, character number 1. So 1, 0, 1, 0 correlates to the number 3. For example, but also I can do this. B in square brackets, I can type -1, -1. It shows 6. Why? Because last class I also told you that this the numbering can also grow from negative, means it can also go backwards. So this is line number -1, -2, and -3. So in line number -1, line number -1, and the -1 character. So this is -1, -2, -3, -4, -5, -6. So I can change this as well. This will show 4 because character number means row number -2 and character number -1. But if I change this, this will show 3 because row number -2, character number -2. So you can actually really play around. Okay, I'll just change this back to say -1, -1. So you can actually play around. But similarly, you can also do, as I told you before, you can also do the positive way, means not the negative way, the actual way. So b in square brackets, I can type say 2, 1. That will also show 6 because row number 0, row number 1, and row number 2, character 0, character 1. So you can do both, from positive like 0, 1, 2, 3, 4, or -1, -2, -3, -4, -5. Okay, let me just create some more rows. Okay, so now, for example, I have an array. Okay, for example, if I type b, this is how the array looks, means in the form of rows and columns. But by using this command known as reshape, I can change the order of the array. So for example, I can type b.reshape, and then I can put parentheses, rounded brackets, and then inside the rounded brackets I can mention my values but using square brackets. You can do it directly, or by again using rounded brackets. It generally suggested to use double rounded brackets, but you can use any formula. So I can type say 1, 6. So it is arranging my array starting from 1, 2, 3, 4, 5 to 6. Okay, 1, 2, 3 to 6. Okay, because there's 6 values. Similarly, for example, I can shape it b dot reshape, say 6 comma 1. 6 comma 1. Now as you can see here, 1 comma 6 does not describe the range 1 to 6, but instead describes the number of rows and columns. So in this 1 row, 6 columns. In this 6 rows, but 1 column. Understood, right? It's really interesting to learn, you know. Once you understand the concept of Python, it's really interesting to grasp it on. So as I told you, we can reshape it, you know, by using the command, the variable dot reshape. And okay, and let me just, you know, do that variable again. So now, this is how the actual variable looks. This is how the reshaped variable looks. Now, what I can do is I can transform the variable. I can transform the variable. So for example, b dot capital T, okay, b dot capital T, and if I execute this, it transforms. Means here it has say here it has 2 columns and 3 rows, but here it's the exact opposite. It transformed it to the exact opposite. So there it was 3 columns and 2 rows. Here it is 2 rows and 3 columns. So you can use the command dot t after the variable to, you know, transform it to the exact opposite. But make sure, you know, the t is a capital T, okay, and not a small t. So let's create another variable called array. Let's denote it as ARR. Now the ARR, you know, array variable, ARR is equal to our NP array, and let's say, okay, let's say I want the numbers. Say I can do it in any order. Say for example 10, 23, 326, 55, 34, just a bunch of random numbers. Okay, just a bunch of random numbers. And if I execute this, if I execute ARR, it, you know, gives it in that same order: 10, 20, 23, 326, 555, 34, 24, 100. But what I can do is I can arrange it in ascending order. So this is how a normal array looked, and then what I can actually do is I can arrange it in ascending order. So for example, if it is 10, 23, 36, 326, 55, 34, 24 and 100, what I can do is np numpy dot sort, and if I do this, nothing happens, and it just shows a bunch of, you know, random things like function numpy dot sort, axis one, kind none, order none, because I haven't, you know, described which variable I have to sort. So but in this case I want to sort the variable ARR in ascending order. So I can sort ARR and I can sort it in ascending order. See, 10, 23, 24, 36, 55, 100 and 326. I can make changes here and as you can see, it has been sorted in the similar way. If I add a 0 over here, it's been sorted in that same way. So, you know, once you make an adjustment to a variable, then it is once you make an adjustment to the variable, and after you execute that variable, all the other code, once executed again, will automatically adjust itself according to the variable adjustment. So I hope I give you, you know, I taught you about numerical Python, which is NumPy, and then, you know, I taught you how to import NumPy. If you haven't followed from me from the starting, okay, if you haven't followed from me and you, for example, you didn't use Anaconda, you can use say exclamation mark pip install NumPy, but we have already installed, so we can I taught you how to import it, and I also taught you how to find the version of NumPy you are using. Okay, in my case 1.18.5, and I taught you more about arrays from the list in NumPy, like how to create an array, you know, how to find the shape of an array, you know, how to arrange it in rows and columns by using the shape. And then I taught you how to arrange a number, like for example NP zeros in 10 means 10 zeros. I taught you identification matrix, which, you know, creates a table with a single number running, you know, diagonally. And for example, I taught you how to fill, means how to fill an entire table by using, the same number. I taught you how to do, the numerical dimension and dimension, then the size of the, variable, and then, how to find the type of the variable by typing .dtype. And then, I taught you many things like how to reshape, how to transform, and how to just sort arrays. So I hope I gave you a brief understanding about numerical Python NumPy. What is numerical Python, its features, its functions, and I hope I gave you a brief introduction and an explanation about arrays and its various functions. So I really hope you enjoyed this session. I will be posting more sessions in the future because I'm currently free. And yeah, I hope you enjoyed the session 4. Please like and comment, share and subscribe. Please like and comment, share and subscribe. And I'm really looking forward to seeing you in my next, Python series. Bye guys. Until then, it's me, Roshan Kanna, signing off.